Projectile is basically an object that is acting under the influence of gravitational force. Do you understand? A projectile basically is an object that is moving under the influence of gravity. Do you understand? In the last two examples that we are given, that is the one I wrote here, when we have a ball, we have a boy that hold the ball and throw the ball down. You understand? This is a typical example of a projectile motion. That is, the ball acts under the influence of gravity. Do you understand? And another example that I do like this, as the ball was thrown up, it acts under the influence of gravity. It is the gravitational force that enables the ball to come down. Do you understand? So that is what projectile motion is all about. Now, both examples are one-dimensional projectile motion. Are you getting it? Because we only resolve the motion, we only resolve the velocity and the acceleration into one component. Are you getting what I'm saying? That is the x-axis. Now we are going to deal with two-dimensional projectile motion. Let's assume that we are given this is the ball. Are you getting it? This is the ball, and we have the earth. Okay, don't forget, a projectile refers to an object that is acted upon by gravity. I guess what I'm saying. When the motion of an object is acted upon by gravity, we can say that we can call that motion projectile motion. But the body that undergoes projectile motion is known as what? Projectile. Now let's assume that this ball is kicked at a velocity of 5 meters per second. You understand? The ball is kicked with a velocity of 5 meters per second. Now, the ball will travel typically along this path. Okay? Now, the path which the ball travels is known as trajectory. Do you understand? Trajectory. You understand? The path which a projectile travels is known as trajectory. Now, let us determine the velocity of the ball along the horizontal axis, along the vertical axis. Don't forget, from our cardinal point, this is what? Positive y, positive x, negative x, and positive x. Do you understand? So now, the ball moves towards this point. You understand? So this is along the x-axis. Do you understand? So now, let me create another table. T, Vx, velocity of the ball along the x-axis, then velocity of the ball along the y-axis. So at time t equals to 0, the velocity of the ball along the horizontal axis is what? 5 meters per second. So this is what? Plus 5 meters per second. Do you understand? So now, what is the velocity of the ball along the horizontal axis? Can you guess? No. It is not. It cannot take any value. The velocity of the ball along the vertical axis is 0 because there is no movement. You can see the ball, at 4 seconds, the ball travels towards there. Are you getting what I'm saying? So the velocity of the ball along the vertical axis is what? 0. Do you understand? So this is what? 0 meter per second. Do you understand? But immediately the ball got to this point, it begins to what? Decrease. The height of the ball begins to decrease. Now, at 1 second, what is the velocity of the ball along the horizontal axis? Let me call this point A. Are you getting it? Let me call this maybe point B. Let me call this 1 second. Okay, at 0 seconds, 1 second. Let me call point B 1 second. Okay. So now, what is the velocity of the ball when the ball got here? What is the velocity of the ball along the horizontal axis? And what is the velocity of the ball along the vertical, along the vertical axis? What is the velocity? The velocity along the horizontal axis will still be constant. Are you getting it? The velocity of the ball along the horizontal axis will still remain plus 5 meters per second squared because the ball is not acted upon. The gravitational acceleration only affects the vertical movement of the ball. Do you understand? Gravitational acceleration only affects the vertical movement of the ball. That is, when the ball travels vertically, that is when acceleration, the gravitational acceleration affects it. But it is not when it travels horizontally. Do you understand? So now, the velocity of the ball along the horizontal axis will still remain plus 5 meters per second. So I'm going to have plus 5 meters per second. But the velocity of the ball along the horizontal along the vertical axis, that will be what? Negative 9.8 meters per second squared, because the ball is now moving towards the direction of negative y-axis. Do you understand? So I'm going to have minus 9.8 meters per second squared. Do you understand? So now, that is for 1 second. Let's assume that the 2 seconds is here. What will be the velocity of the ball along the horizontal and vertical axis? The velocity here will still remain plus 5 meters per second. Do you understand? But the velocity of the ball along the vertical axis will be what? Minus 19.6 meters per second squared. Oh, sorry. This is meter per second, okay? This is meter per second. Do you understand? Please, don't be confused. We are dealing with velocity here. We are not dealing with acceleration. Do you understand? So, this is what? Meter per second. Do you understand? So, now let us proceed. So, the velocity of the ball at 3 seconds is what? With this will still remain plus 5 meters per second, and this will be what? Minus 29.4 meters per second. Do you understand? So that is the relationship between velocity and gravitational acceleration of a projectile motion. Do you understand? In summary, when we are dealing with projectile motion, the velocity Vx of the object will not change unless if you are given a special case. Maybe the object is acted upon by another horizontal force. That is when the velocity can change. But if there is nothing like such, that means the velocity remains constant. As you can see, the velocity is constant for every phase of the time. I get what I'm saying. So that is projectile motion. You understand? So it's very important that you note that. Okay. Now let us have another example. Okay, let's say we have a ball here, and the ball was kicked. The ball was kicked, and then it travels through this trajectory path. You understand? Okay. Let's say the ball was kicked with a velocity of 29.4 meters per second. Do you understand? Let's say the ball was kicked with this velocity. Now, the question now say, let's say along the x-axis, that is Vx, Vy. Along the y-axis, that is Vy. Velocity along the y-axis is this, and the velocity along the x-axis is say 5 meters per second. Do you understand? Okay. Now, what will happen to both Vy and Vx after 1 second? Please, I want you to pay attention. What will happen to both Vy and Vx after 1 second? Let us have another table. Okay, we have time, we have Vy and Vx. Let me put Vx first. Vx and Vy. Do you understand? Okay, now, what will happen to both Vy and Vx after 1 second? At 0 seconds, the velocity of Vx is what? 5 meters per second. The velocity of the ball along the along the horizontal axis is what? 5 meters per second. The velocity of the ball along the vertical axis is what? 29.4 meters per second. Now, in 1 second, what will happen to this velocity? Let's say this is 1 second. Okay, the ball gets here. This is 1 second. What will happen to the velocity of the ball along the horizontal axis? Don't forget, the velocity will still remain the same along the horizontal axis, because the gravitational acceleration only affects the velocity of the ball along the vertical axis. Do you understand? So the gravitational acceleration does not affect the ball along the horizontal axis. Don't forget what I told you that the acceleration does. Acceleration tells us how the velocity of the object changes with respect to time. So the velocity of this object will only be affected by the acceleration, the gravitational acceleration, because the object is traveling along the vertical axis. And I told you that the gravity tells gravity causes an object to fall. I get what I'm saying. So now, an object that is traveling either vertically or either upward or downward will be affected by the force of gravity. Are you getting it? So now, what will be the gravitational, what will be the velocity of the object along the horizontal axis? That is what? 5 meters per second. So this will be what? 5 meters per second. Along the horizontal, along the vertical axis now, what will be the velocity of the object? The velocity will what? Decrease by 9.8 meters per second. Do you understand? Because at 1 seconds, the velocity will decrease by 9.8 meters per second. Though the velocity is positive here, but it will be increasing at a decreasing rate. Do you understand? So for the 1 second, the velocity will change to what? 19.6 meters per second. Do you understand? Because the gravitational force of the earth, which is the gravitational acceleration, is what? Minus 9.8 meters per second square. This has acted upon the object. Do you understand? It has acted upon the ball. As the ball was shot, the velocity is here, but immediately the ball was in the air. What happens? The velocity is affected by this. Do you understand? So now this the velocity has reduced to this. So at 2 seconds, the velocity along the horizontal axis will still remain the same. That is 5 meters per second. But the velocity along the y-axis will still be reduced to what? That is 9.8 meters per second. So at 3 seconds, this will still remain the same. So at 2 seconds, the velocity here still remains 5 meters per second, and the velocity here is what? The velocity here is this is 19.6, this is 9.8. So at this place, the velocity here is not even increasing again. At this place, the velocity here is still 5 meters per second. This is what? 1 second, 2 seconds, 3 seconds. At 3 seconds here, the velocity is, the velocity along the horizontal axis is what? 0. That is Vx. But this still remains the same. That is what? 5 meters per second. Do you understand? So now, at this point here, the ball is not moving upward. Are you get what I'm saying? The velocity of the ball is 0. So at this point, the ball tends to what? Come down, because this is the maximum height. Do you understand? So the velocity is what? The velocity along the vertical axis is 0 meters per second. Now, for the 4 seconds, the velocity will still remain the same along the horizontal axis. So the velocity along the vertical axis is minus 9.8 meters per second. So for the 5th, the velocity will still remain the same along the horizontal axis. The velocity here will be what? Minus 19.6 meters per second. So for the 6th seconds, 1 2 3 4 5 6. Do you understand? So along the y-axis, along the x-axis, 5 meters per second, and minus 9.8. You understand? For this is what? Minus 19.6, and this is 5 meters. Don't forget, the velocity along the horizontal axis will always be constant. So this is what? 5 meters per second, and this is also what? 5 meters per second. But along the vertical axis, the velocity is increasing, because this is what? Minus 29.4 meter per second. This is minus 24. Minus 29.4 meter per second. This is 5 meters per second. Now, I want to take note of something. When the velocity is positive and the acceleration is negative, what happens? The velocity begins to decrease. Do you understand? But immediately the velocity becomes negative and the acceleration is what? Also negative. What happens? The velocity will increase. Are you getting what I'm saying? So that's it. Let us move to Newton's 3 laws of motion.